Hey, welcome to another lecture on programming in Python. Today we're going to be talking about loops, what they are, how to control them, and how to work with them. So a little bit of background as always. So far, if you've been keeping up with the course, you've learned how to sort of store values in the computer, how to reference them, um, how to make the computer check, make some basic decisions, check if things are bigger or if they equal. But so far, everything that you've done has been something that you sort of have to predefine in your program. Um, while you might have a little tree of decisions that can be made, you're waiting for a user input to decide um, how the program's going to progress and things like that. One thing that we've been kind of missing out on is one of the key things that makes computers so useful, and that's that they, as we talked about, they can make decisions very accurately, which is what we've done, but they can also make decisions very, very quickly, right? A computer, if you look at modern processors, are usually working in the gigahertz scale. Now, and what does that mean? A hertz is a cycle per second. Giga is a billion, so they're usually working in billions of cycles per second, and a cycle can actually have multiple calculations. So billions and billions of calculations per second. And obviously, we really want to take advantage of that. So, in order to do that, what we want to do is learn how to make the computer sort of work as hard as it can, do things as fast as it can, do a bunch of things that we still predefine, but nevertheless a bunch of things rather than just one or two at a time. And there are, obviously a bunch of different ways you could do that, but the most basic example is doing what's called iteration or looping. And what does that mean? It just means part of the code that will, as the code is evaluated, your sort of compiler or code reading software comes down, line, and we put some sort of statement here that says, this next block of code, you're going to run through it, and then you're going to make some kind of check. What is some sort of conditional statement, and if it's true, you're going to go back to the start, and if it's false, you're gonna run through this code and then just continue on down your list of code. In Python, there are only two ways of making loops. And I guess a little caveat here is that this is, most of the stuff I'm teaching, including this, this is the sort of default Python. There are libraries and things that can add other ways of looping and things like that, but the default Python language only has two. The most simple in most people's minds, what most people find the most straightforward way to do loops is with what's called a while loop. So I've opened up my PyCharm. I've created a new file called loops.py, and so far all I have it doing is printing done, so that I know that this is finished, and that all works. Everything's happy. So the first thing I'm going to do is define a variable. Let's say var1, our good old variable names, equals 0. And that's again a number. Python figures that out. And let's do a nice simple explanation, or a nice simple example where we will do while. And as we talked about a number of lectures ago, Python comes through line by line and then goes left to right. You know, here it says var1. I don't know what that means until it gets to this operator. Then it says, oh, var1 must be a variable. This equals operator is going to take the value on the other side and assign it to that variable. When we get to this line with while, what the compiler is going to do is it's going to run across this line left to right, and it's going to say while, and it will say, I don't know what that is, because you need to tell it while what, right? If while the compiler has recognized this while as some sort of key phrase, it needs to know while what? While the sky is blue, while the time is less than 60 seconds, there's while needs to have some sort of clarification. So you put a parentheses in, and let's say while var1 is less than 5. And then you give it a colon, just like the conditional statements, if else, they all get a colon. And then Python, being the kind of strange language that it is, needs you to start tabbing, putting a tab at the start of each line. And that's how it knows how much code it's going to do. So let's just do this. Let's have it print the value of var1. And let's have it print var1 2 times, just so that we know what we're doing. And then at the bottom of this block of code, let's take the value of var1 and assign it, right? Since we've already defined this variable, now when we put this equal sign here, we're reassigning it. We're assigning it a new value. But we're going to do something kind of funny here. And we're going to do var1 plus 1. So what that does is it says, as this line is evaluated, it says, all right, I see Python comes over here. It says, I don't know what var1 is until it gets to this equal sign. And it says, oh yeah, var1 is a variable. And what are we going to assign its value to? Now, when it does that, it looks at the right side of this equal sign and it says, I'm going to evaluate all of this, do some sort of mathematics and just dump whatever the outcome is and store it here and move on. So when it evaluates this side, at first it comes through and it says, it evaluates this and it says, what is var1? I know that's a variable. Its value is currently 0. So it says 0 plus 1. All right, that equals 1. So var1 is now 1. And then it says, I'm done with this loop. There's no more tabs here. I'm going to go back to the start. And it will say, while var1 is less than 5, I can continue. So var1, now at the end of this loop, its value is 1. So then it's going to come through here, print its value a couple more times, and then it's going to get down to this line again, and it's going to say, var1, what is that? It's a variable. What are we going to do? We're going to assign it a new value, and we're going to assign it var1 plus 1. So it's going to say, what is var1's value? It's 1 now. So now it's going to say 1 plus 1 equals 2. var2 is now 2. And then it's going to come back up to the start of this loop, and it's going to do this over and over again until it gets to 5. And then at 5, it's going to say, what is it says while var1 is less than 5. Well, var1 is now 5, so it's not less than 1. Or sorry, not less than 5. So at that point, it's just going to exit the loop. It's going to continue on, skip all the rest of these lines, and continue through the rest of your code like you are, doing just line by line again. So let's see if that works. And there we go. So we have it printing, starts at 0, goes through, does all those things, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and then it gets to 5, and it doesn't print anything because we wanted it to be less than 5. So that's cool. Very useful. You can probably already see, for one, you could see how quickly that evaluated, how quickly that printed all of those numbers. At the moment, what your computer is going to do is when it runs this Python code, it's going to run it as fast as it possibly can. So while the computer has to do a lot of other things, it's not going to run it at actually billions of calculations per second, but it might do very well millions of calculations per second. So it's going to do this very, very quickly. How about, what if we wanted to say, I only want to print even numbers here. I only want to do my calculation with even numbers. How do we do that? So you have a couple different options, right? And we can talk about the benefits or not benefits of doing this in a moment. But for the moment, I'm going to comment out these. And we're going to do another loop. So after this loop finishes, var1's value is 5 now, right? So we can just put a comment in here so we don't forget. var1 is or should be 5. And so if we tried to do another loop, it's not going to do anything, and we can always check if that's true. We played, I had commented these out, so it skipped printing those lines, and sure enough, var1 is 5, so it moved on. Didn't even bother looking inside of this loop. But okay, let's make this 20 now. So let's say we only wanted to print the odd values of var1. So you could do a simple if statement. If sorry, thinking in C suddenly. If colon, because we're working in Python, I'm going to introduce something that I probably should have introduced in the conditional statements, or maybe even in the math statements, but I'm going to introduce the modulus operator here, which, what does that do? It's essentially just the remainder. If you remember learning division back in school, you learned that you can, divide 4 by 2 evenly, but if you divide 5, you have to have a decimal point, or you can divide it by 2 and then have a remainder of 1. Modulus gives you just the remainder. It's actually quite an important calculation tool in programming for a variety of reasons, so it's built very low level into every programming language, but the way you denote that, they give it a special symbol because it's so important. So we say if var1 mod 2, var1 mod 2, and what that says is if var1 is divisible by 2, we are going to, and we're going to print var1 again. And then we are going to add another one to var1. And as it goes through here, you'll see that this if statement is only going to be true every other number. So we should only get odd numbers now. Or sorry, even numbers. Oh, I messed up. Equals, sorry. So what this says is if you divide this number by 2, it should have a remainder of 1, which is what the definition of an odd number is. Then you should print it. And I guess if you might have caught there for a moment that I had not actually put this equality check right here, and it still printed the odd numbers. How did it do that? The true and false keywords in Python are sort of aliased to 1 and 0, right? Boolean logic, 1 and 0 is true and false. So if I actually just deleted this equals, it's actually still accomplishing the same purpose, because it's only going, if you take the modulus of something with respect to 2, you're only ever going to have 1 or 0. So functionally, you're just true or falsing by taking the modulus of 2. Not exactly something that's too important here, but it's worth noting if you caught that happened. So, all that being said, that's one way to only print an odd number. But what if we had sort of a more complicated check? Something that wasn't as simple as just a modulus, where we wanted to skip, let's say my least favorite number is, let's make a new variable, least fav is 11. Just cuz. Let's just say I hate 11. And so I don't want to print 11, but I know it's going to pop up in here, right? So in order to just avoid, say, this one number, let's add another check, but we'll associate with this check our first loop control. So first control that I'm going to show you is called continue. So inside of my if statement, and I could put it, and actually it might look cleaner if I put it outside of the if statement. Let's say before I check if it's odd, I'm going to check something else. And you can do as many of these as you want. If var1 equals least fav, well, I don't want to see number 11 because I hate it. So instead of going through here, instead of even bothering doing calculations with 11 because I hate it so much, I'm just going to continue. So what does this word here mean? What does this do? Oops, no semicolon. What does this do? Well, if a loop ever sees a word continue, it will immediately skip to the next, to try to evaluate the next step. I'm going to run this, and we're going to run into an issue right here. And you might be able to predict it if you paid attention to what I just said. When it gets to the step, it's going to hit this continue statement and immediately go back up to the top of here. It's not going to bother running through the rest of this code. So if I hit play here, so my code did 579, it got to 11, continued, and now it's running. It never printed done. It never printed any other numbers. It's literally sitting here running. So in order to get out of this, I have to manually stop this code. We're going to get an error because I manually stopped something. And what just happened? Why did that happen? Well, the while statement runs as many times as you want to, right? The only control here is what var1 is doing, right? It can run for infinity. So when I did this, if var1 equals least fav, and then continued, it got 5, it got 7, it got 9, and then it got to 11 and said, okay, var1 equals 11, I'm going to continue. And then it went back up here and said var1 is less than 20. And if var1 is 11, continue. All right, if var1 is less than 20. All right, if var1 is 11, continue. And it just ran forever. Because down here is the very last step in my code is when I decided to add a number to var1. So if I want this to do what I want it to do, I have to tell it before you continue, if it's 11, add one more. So now when I go through here, everything finishes properly. All right. So that's all fine and dandy. What about if I actually hate the number 11 so much that if I ever see it pop up, I just want to quit. I don't even want to continue doing anything. I just give up. So that brings you to the next statement here, control statement for loops, which is a break statement. And it does pretty much exactly what it sounds like. I'm going to comment out this continue. It breaks the loop wherever it is. It just says, wherever you see this statement, we're done. Move on. So I've replaced my continue statement here, and var11 or var1, if I ever see 11 here, it's just going to exit this loop. It's going to add 1 to var1 and then exit the loop technically. So what do we get when we play this file? 579, and then we see 11 pop up, and we just say screw this, and we break out of that loop and we finish the program. So you might say, what's the point? Why do I have to define this conditional up here if I can instead, what is the difference between doing that and doing say this? If var1 is greater than or equal to 20, then continue or break, right? Because right here this is saying every loop check if we're greater or if we're still less than 20, and then do the loop stuff. And right here we say, well, at the start of this loop, var1 needs to be or if var1 is greater than 20, leave the loop. The answer is that these two things are functionally the same, and there are certain cases in code where you might want to do something really, really strange looking, like having all of your control statements inside of your loop and doing something like this, I'm going to comment this first line out so that we can keep in mind what was going on, but doing something like this. Right? So if 1 equals 1, we loop. Now, on face value, right, this is always true. You're always going to be doing this loop. This loop will always continue. And if we didn't have this statement right here, this if statement with a break, it would run forever. So doing those two things, having a while statement with a conditional check at the start, and a while statement that's always true, and a conditional check with a break statement, are functionally the same thing. The only real difference is there are certain times when having a weird check like this in your actual loop is something that you want to do. Funny enough, you'll see it pop up in places like design of GUIs. So environments where you're sort of sitting there doing nothing for a really long time and you're waiting for something to happen, waiting for something to change. And this is actually the basis for what's called event-based programming, where you have a program that is mostly not doing anything, and whenever something happens, it does a lot of stuff. But that all being said, for most if not everything that we're doing in this class, you're just going to go with how the sort of normal, have a conditional check right at the start of your loop. So now you've learned how to do a while loop. You've learned how to do some of the basic controls for how to leave loops, how to skip lines of loops. But there's one other type of loop we have to learn about. And there's not really you can accomplish everything with your while loops, and you can also accomplish everything with this next coming loop. But there are certain times where you might find your code easier to think about or more optimized, able to run better if you use one versus the other. And our second loop in Python is a for loop. So just like a while loop, you say while this thing is true, I'm going to do these operations. The for loop is very close. So you say for, well, for what? The for has to be, a for loop has to be accompanied by an additional keyword. So first of all, you have to define a variable. So let's say, since I already have var1, let's say var2. So this is what I said, you need two keywords in a for loop. You say for what? For this var2 in what? And the most common thing to put after in is a range. And just like some of the other statements we've learned about in Python, range is one of these built-in fancy Python functions. And what does it do? It does a few different things depending on the arguments you give it. The first thing it can do is just make a list of numbers from 0 to whatever you tell it. So let's see how that works. Let's do 3 so that we're not printing quite so much. Print. Oh, and then you need your good old colon. Print 3. Or var2. So what is that going to do? After we've done all this nonsense up here with our while loops, we're going to move on to this for loop, and it will say for what? some variable that I just made up in this list of numbers from 0 to 3, print var2. And what this means is it made a variable here to store something for this loop. And what is it storing? It's one at a time for each one of these loops. It's storing whatever value is in this list of numbers and evaluating the loop for that value, that specific value. So it will say var1 is 0, var1 is 1, var1 is 2, var1 is 3. And to see if that's true. Oh, actually, wait, it's the range syntax is a little bit funny. I believe it's actually 3 numbers from 0 onward is actually the way this is. So it's 0, 1, 2, 3 numbers from 0 up. If we want to get around that weird range syntax, let's do this a little bit. Say we didn't want to go from 0. We want to go from 1 because we like one base numbering, I guess. So now we're going from range. And if you're ever not sure, this is another thing you can just get the IDE to show you. So if you mouse over it, and show me, come on. There we go, fetching documentation. And we can just click there and it will show us. We can use range as a start or as just a stop. We can use range as a start, stop, and then a step. So let's just use it as start and stop, which is 1 to 3, and it will take all the numbers between 1 and 3 and print them. So now we should have 1, 2, and 3 is, I believe, not inclusive. There we go, 1 and 2, that is right. And so why does all of this, why would you ever use a for loop instead of a while loop? It seems like it's kind of easier to control this variable right here by doing the operations yourself. There are, especially when we get to things like when we talk about ordered lists later, there are sometimes when you don't really, you want to do a set of calculations, but you're not doing them on 0 to 10, right? You're doing them on specific targets that aren't really in an order. But as I said, you can do, and so a lot of times in one of those lists, might be more obvious to people to put them in a for loop like this. But when I said earlier that you can accomplish all of your tasks with a while loop or all of your tasks with a for loop, and it just comes down to sort of like preference for each one, you can just number the objects in your list and then do a while loop. So in the end, they functionally accomplish the same tasks, and it's just sometimes you will, one of them will make more sense to you versus the other, and sometimes there will be a sort of an optimization consideration. Maybe you have to do one less calculation per loop to accomplish your task. All right. So, with that all being said, you've now seen the two basic kind of loops, and you've seen the controls that can sort of control their behavior mid-loop, right? Skipping lines, breaking out of loops. But this may seem somewhat simple. But this is really where you really should start to think about the ideas of optimizing how many things you're asking the computer to calculate. You can very quickly start bogging down the computer trying to calculate a bunch of things very quickly. And in fact, what you'll see very soon is the idea is how easy it is to exponentially grow the number of calculations that you're doing. So for example, let's just go back to printing the numbers from 0 to 2 in this for loop. Let's take it up to 5. And now, instead of printing with that, let's put a for loop right here. So I have a for loop and then a tab and then another for loop. And let's change our variable to var3. And we're going to print var3. So now what have I done? Functionally, I have turned my number of print statements from 5 to 5 times 5. Right? Every single time this first for loop runs through, it's going to restart this second one inside of it. So in doing that, I've just squared the number of calculations, the number of things I have to print to the screen, and made it, let's do, let's add a line skip here so that we can see this happening. So I've just, squared the amount of outputs that I have to do. And you could see very quickly, for 5 numbers, that's not a big deal, but, make it 50. What's 50 squared? It's 2,500. You're very quickly increasing the amount of calculations and things you have to do per step. So welcome to the wild world of optimizing code. It wasn't something you had to care about until now, but it is something you should start to think about now. So I guess that's really all that we need to talk about for the basics of loops. There's a lot of complexity to this idea, and you'll see very quickly how you functionally just learned a big part of the meat of coding. But it's best to learn about it by breaking things and sort of, getting the experience. So for now, that's all there is to know about loops. I'm going to save this file, and I'm going to, as I pointed out in the past, I'm going to commit the changes so that all of this gets saved and I don't lose access to it in the future. Thanks, and I'll see you next time.